Hello everyone, this is Surya. Welcome to my channel. This will be a progressive web app series, or PWA for short. It's a nice set of features for your web app so that you can add native mobile app features like making your web app installable, then caching your resources so that it could work offline, background sync so that you can do some work when you're offline, and it could be synced up to your backend server when you're back online again. So really nice features that you can now incorporate in your web apps through some libraries. So in this video, we'll look at how to make your web app installable so that it can be easily accessible like a native mobile app with a single click. So that way, reducing the pain point of going to the URL in browser and making it more user-friendly. So I'll be using a simple e-commerce app to demonstrate the PWA features in this series. So I'll be using the Chrome browser throughout this series to work on the app and incorporate different PWA features, because there is extensive support for PWAs in the Chrome browser compared to the other browsers. Yeah, let's get started by taking a look at the sample web app that we'll be working with. Okay, so we are in the Chrome browser, and here is the sample web app I was talking about. It's also responsible with respect to the top image being rendered responsively. So yeah, as you get smaller, you can see it's able to render image of a different size. So let's maximize it. Let's open up the Chrome DevTools. So these are quite handy. So the shortcut for that is Ctrl+Shift+I if you're on the Windows. And here you have this tab to toggle between the desktop and the mobile view. So once you do that, you see it neatly gives you that mobile frame. It's a Galaxy S5. So here you can scroll up and down. You have some default products that you can shop. So since it is an e-commerce platform, and you have a button that gives you a way to add a new product. So it's not exactly completely functional at this time. So you have fields to enter different details of the product. Then you also have a way to add it to cart, add it as a favorite. So let's add it. So you see that nice indication of items being added to the cart. Let's add all the items. So you see you have that snack bar and also the count being updated here. So once you click on that, you have a display of the items that are being added to the cart, and the total price is also being computed. You also have the option of being deleted, but it's not functional at the moment. Also the checkout. So you also have the sidebar, so which you can get by clicking on the hamburger icon to subscribe. So all of this is just bare bones sample e-commerce app. We'll be adding different PWA features, and we'll see a more functional app. Now let's get into the code. Take a look at the sample app here. Since this is a PWA series, we won't be covering the whole development process of this app, only parts of it where we need to add the PWA features. So I'll be using Visual Studio Code, but you can use any other editor of your choice. And with that, let's get into the code in the Visual Studio Code. Okay, we run the Visual Studio Code. So let's start with the package.json. So this will be a node project, and you can see the node modules here that have been installed. In the package.json, you see that we have a dev dependency, which is the HTTP server. It's also a package. So our web app, simple e-commerce web app, it will be rendered through this local HTTP server. So that's the reason we have the public folder. That is kind of the requirement when you use the HTTP server package to render all the resources in the public folder. So within the public folder, we have the source folder, and then we have the CSS, images.js, which is the JavaScript subfolders, so that you can organize your code of your web app. So starting with CSS, So we have some sample styling for different elements. I'll be using Material Design Lite. I think it's a neat framework that has some pre-styled components and classes. And then you have the images. So you have different icons. So for the favicon, we have a shopping cart icon of different sizes. And then we have the images for the different products, the 3 products that we have on the landing page of the web app. And also the top image that keeps changing the size based on the size of the viewport. So these are the images, and then we have the JavaScript. You go to app.js, it's empty. Like I said, it's kind of bare bones. We'll be adding functionality as we incorporate different PWA features. And then we have the new product. That is like when you click on that floating action button, like the plus icon. So to add new product. And then the product listing, which handles rendering different products that are there on the landing page. And then we have the index.html, which is kind of the landing web page. So here we have the header section where we have the linked style sheets of the Material Design Lite MDL and our custom style sheets, the home.css and new product. And in the body, we have the tags to render all the sidebar, the shopping cart icon, then the listing of the products, and also the rendering of the custom top image size using the source set and the sizes attributes in the image tag. And at the bottom, we have the script tags for different JavaScript files that we have in the app. So if you're interested in knowing how to create images of different sizes and making it responsive using the source set sizes attributes of the image tag, and also the HTTP server package, how to use it, and the command here. So all of that has been covered in a separate video. So you can find a link to that at the top right corner. So do feel free to check that video out before you get on with this one. Also, all of this code is available on GitHub. I'll leave a link to the repo in the description. So you might want to clone that repo before you get started and possibly code along with this video. So before I go over the JavaScript part, let's go back to the Chrome browser and look at the icons and the image I was talking about. Back in the Chrome browser, this is the favicon that I was talking about. It's at the top of the tab in the left corner, and this is the top image. So here it has the width of 360, height of 640 for the Galaxy S5, and it fits right at the top. And if we switch to the desktop view, you see you have a change in the image size with the change in the viewport, like we saw earlier. So you see the change in the pixels and the image changing its size too. That is what we saw in the images folder in the Visual Studio Code. Back to the JavaScript. Let's look at the product listing.js. That is where all the logic is there to store the product data and render them once all the HTML elements are loaded. So right now we don't have a backend like to store the data for the network. So we're storing it locally within the app in a map. So that is the products app. So here you have logic to just add items to the map using the set method. So we have that initial 3 product items that we saw, like shoes and glasses, the retro camera. So, and then you have the image URL, which is the path to the files here within the app, images and the products folder. So then we have some HTML elements within the index.html to display the shopping cart and the badge, like the number of items currently in the shopping cart, and also the menu, which is the MDL, that is the Material Design Lite class that we have there. So we're using that as the identifier or the selector to access and accordingly populate that with with product items. So on window load, once it's all loaded up, then we set the initial data batch, like for the shopping cart, like the number of items currently in the shopping cart. So since we're storing it locally, each time we refresh it, it'll be 0. So that'll be like the initial state of the shopping cart. Once we add the backend later on in the series, we'll be storing that remotely and fetching that over the network each time the app is loaded. But for now, it will reset each time we refresh the page. So you also have the logic here to render different elements within the shopping cart. Like if it's empty, so you just render some custom content there. And then if you actually have some items, you create those items dynamically and then add them to the menu there. So same way, you have a loop here, which loops with the values of the products map. So if we hover, it's of type map, which stores all the product data. And for each product, you access the data and you create HTML elements and add the data to the items, like the name, the price, the image, everything. So that is what you have here in the product listing.js. Do clone the repo and go over the code if you're curious as to how it has been implemented. So here is the logic for the snack bar too, to show up each time some action is performed, like adding a favorite or adding an item to the shopping cart. So next is the new product. This basically is the form that takes in the data for the new product and it will add it to the list of the products or the map of the products. So you have these selectors where you get access to different elements on the DOM, which is the document object model, essentially a tree of different HTML elements on the web page. So once you have access to that, then on the click of that plus icon or the floating action button, you perform an action. So which is changing the styling, basically changing the display from none to block so that the form is visible and the prior elements are hidden, so display set to none. This is a simple vanilla JavaScript implementation, so no frameworks like React or anything. So that is all the code we have right now. Simple code for a simple app. So now to make your web app installable so that it's easily accessible with a single click, like a typical native mobile app, some criteria has to be met so that the browser gives you the option of installing your web app. Let's get into the details next. So here is a nice blog post from Pete LePage from Google on the criteria that is to be met for a web app to be installable, like a PWA. So if we scroll down, we have the criteria here. So it's all based upon the before install prompt. That's an event that will be fired when the criteria is met. These are the things that entail the criteria. First thing is the web app, it's not already installed, and some user engagement heuristics, like how many times users visited, is interested in the app or not. And it has to be served over HTTPS, that's your web app or your website. So localhost, that is an exception. So since we're just doing the development locally and not deploying it to the production environment, the localhost would work for us. So then we have the web app manifest file. That is a way to configure your web app so that your browser knows how to custom render your app when accessed on a mobile device. So we can configure different aspects of the web app. Like you can give it a name, I can give it a short name, and then also the icons, like depending on the viewport size, which icon size to render. Then the start URL, which is like the starting or the landing page of your app. Then the display, whether it should be standalone, full screen, different options are available, and there are a lot more other options. We'll look into it. The final one is the service worker. So you have to register a service worker. That is kind of a crucial building block for the PWA because it runs in the background and handles different actions like caching static resources, intercepting the fetch calls to render data resources over the network, then the background sync, notifications, and so on. So it's really important to implement a service worker, and the criteria entails having a fetch event handler, like to intercept the fetch requests that are made by the web app and accordingly perform some action based on our needs. So that is all the criteria that we have. So the first three are kind of covered because we haven't installed any PWA yet, and we have the local host to satisfy the HTTPS requirement. Next is the web app manifest, so let's get into that next. So if we go to caniuse.com, that is a nice resource to check out support for different features in different browsers. So here, if we type in the manifest, which is the manifest file, so you can see the description. It is the ability for a user to install a website and use it as if it was a natively installed app. So if we look at the support that is there in different browsers, the Chrome has good support compared to other browsers. So Edge is also starting to support the manifest file, but it's not yet supported in Safari, Opera, but you can see support in the mobile browsers like the Android browser and the Firefox for Android, Samsung, and so on. So globally, it has 86.77% of reach or support. So that's a decent reach, but still more browsers are yet to come on board. So it's a good idea to start incorporating PWA features so that it can lead to a good user experience, taking advantage of different features, and the browsers that don't yet support them, the users just don't experience it. It is a nice way to future-proof your web apps, to start progressively adding features based on the needs, so that when other browsers add more support to the manifest and other PWA features, the users can instantly take advantage of that. So that is about the support for the manifest in different browsers. So there is a nice Mozilla documentation there on the manifest file. So here are different aspects that you can configure for your web app, like the background color, description, the direction of the text, left to right, icons, and so on. So this is a sample manifest file that we have. It's a .json format, so kind of the stringified JavaScript object format. Here you have the keys that are also to be in double quotes. So they're strings along with the values as well. So yeah, name, the short name, those are self-explanatory. Then the start URL, here it's the root of the web app. Then the display standalone, it's typically standalone if you want your app to function as a native mobile app. Then you have the background color. This is usually useful with the splash screen, like the interval when you launch and the app actually loads. So in that startup interval, you have the background color that will be used by the browser to render your app. Then the description, the icons. So icons is an array of objects. So you have the source here. It will have the path, the sizes, and the type. So you have to explicitly give the size, because giving it in the name wouldn't actually help, because you can have anything in the name. So having the size there wouldn't actually help the browser to know the size. So for that, you have a separate field there with sizes and also the type. And you have other options. So this is the way to actually integrate your manifest file into your web app using the link tag in typically the landing page, like the index.html in our case. So the relation would be manifest, and then the href would have the name or the path. Then we have the splash screens, like I said, background color that is used, and also the name and the icon. So the splash screen, it's auto-generated from properties in the web app manifest. So that is how the browser knows like what name, color, and icon to render when launching your web app as a PWA. So there's also another resource from the web dev, that is the Google resource. So I'll leave a link to all these resources in the description so that you can check them out for later use. So that is about the manifest file. And if you go back to the criteria, so that is one thing we need to add next to convert our web app into a PWA and make it installable. So the final one is the service worker. So let's look into that next. So we have another resource from Mozilla. It neatly gives you the service worker lifecycle. So like I said, the service worker, it's a background process, and it's in a separate thread from your main web app thread. And as you might already know, JavaScript is event-based. So it basically reacts to different events that occur, and accordingly execute the functions that are bound to those listeners. So for a service worker, the first step is installing. So that is triggered with the install event. So typically in the install phase, any static files that are to be cached are added to a cache. So we'll look into that in the future episodes, since we're not dealing with caching in this episode. But just have it in the back of the head that some static resources could be added to caches to work offline. Once it is installed, the next step is activation. So that is triggered with the activate event. So this is where when different versions of service workers get installed. Let's say you have an existing version, and then you have a new version of service worker. It won't be activated until the older version is removed. So we'll look into that when we actually write the code and work with the Chrome dev tools. So once it is activated, then the cycle continues with the next version, again with the install and activate. So if you scroll down, here are different events that the service worker can handle in the background. So we already saw the install and activate for the lifecycle events, and then we have the other functional events like the fetch, the sync, and the push. So the fetch effectively makes the service worker as a network proxy so that it can intercept the fetch events that are triggered by the web app, and then accordingly do some intermediate work before sending it off to the internet. So that is how we can incorporate the caching strategies and give that offline functionality to your web app. And similarly, we'll be looking into the background sync with the sync event and then the push notifications so that when the user subscribes, they can be notified like the normal native mobile app. So that's a little bit of theory about the service workers that we need to know to get started. Let's look at the code as well. So here is another resource from the developers.google.com. So more simpler description of the service worker lifecycle, which is the registration, installation, and activation. So let's start with the registration. So here we have the corresponding code for that. So first we check if the browser has support for service worker or not. So that is that if condition, if service worker in navigator. The navigator effectively would be the browser, and with this line of code, you're registering the service worker to the browser. So it is a promise. So if you're not familiar with promises, it is a way to wait on some action so that it doesn't have to complete immediately and get the end result later on when it's done. So since registering the service worker to the browser takes some time, it is a promise, and you can access the end result by using the dot then, and in the function you get access to the registration. So then you can just print out of the console. So if we scroll down, then we have the installation. So since it is a lifecycle event, so you have to register an event listener. So here you see the self keyword. That is the way to give access to the service worker entity, and then to that entity you're adding that listener so that it can react to that install event. So you have the name of the event here, that is the first parameter. Second one is the handler for that event, which is a function. Similarly, you have the activation. So that is also another lifecycle event, and you need an event listener for that to handle that triggered event. So same way, you have the self dot and the name of the event and the handler here. So the registration typically is done in a separate file, usually a JavaScript file that's part of the web app, and then the event listeners to the two lifecycle events are kind of tied to the service worker file itself. So as you can see here, you have service worker.js for both the installation and also the activation, whereas the registration of the service worker, it's done in main.js, which is part of the web app. So now similarly, we need an event listener for the fetch event as well, which is a functional event. So here is an example of that code that we used for the fetch. It is similar to the code for the install and activate events. So you just have the fetch and also the handler, and then you have event.respond with. So since with the fetch event, the service worker would be acting as a network proxy, it has to return the response of that request done with the fetch. So for that, we have the event.respond with, and then we have here additional code for caching. Since we're not discussing caching in this episode, we won't be doing that, but we will cover it in the later episodes in the series. So that is all the theory that you need to get started with incorporating the requirements to make our PWA installable. So let's start with the web app manifest, and then we'll get to the service worker. So we're back in Visual Studio Code now. So let's start with implementing the manifest.json file. Let's create a new file here in the root folder within the public. Let's name it manifest.json. So just to speed things up, I have already written down the content of the manifest file. So I'll just copy paste it here, and I'll just go over the different attributes. So there we have the whole content. Let's save it. So since it's kind of a string-wide version of JavaScript object, the entire content would be within the flower brackets, like starts with that and ends with another brace there. So let's quickly go over the attributes. I've already discussed a few of those in the theory. So we have the name, we're just naming it e-commerce app with PWA features. You can name it anything else. And then the short name, let's call it EComm PWA. Then the icons. So here, as discussed, the source will have the paths to the file. And then the type would be PNG, because in the images and the icons, we have all the shopping cart icons, which are all .png files. And even though we have the sizes in the name of the file, that wouldn't be enough for the browser. So that's the reason we have this sizes attribute here. So for each of the files that we have here, different sizes, we would have to include that in the icons array here. So then we have the start URL. So that will be the index.html, which is our landing page right here. And since it's at the root, it starts with the // there. And then the scope, we give it dot, which is like the current folder. Since the manifest is also at the root, which is the public folder, the PWA will have access to all the pages within that folder and also its subfolders. And then the orientation, we give it portrait primary. There are other options too, like landscape and so on. Since we want the view to stay in the portrait mode, we give it portrait primary here. And then the display, which is a standalone, we discussed that in theory too. Then the background color, we'll just give this color. It's hexadecimal value. You will get to see that color in the splash screen when we actually install the PWA and load that for the first time. Then the theme color, this is another hexadecimal value. It is essentially for the standalone PWA app to have it at the top, like the app bar. Then the direction of the text, it's left to right, since we're working with the English language. Then some description here, and then the language itself. The code is ENUS, so that's United States. So that is all the content for the manifest.json that we need. And now we have to integrate this into our web app. So the way to do that, like we discussed, was adding a link tag to index.html. So right here in the head section, so link, the relation would be manifest. And then with the href, we just give the path. So since it's at the root and also the index.html is at the root, we just give the / here. And then the manifest.json. You can also give it a comment too. So now let's go to the Chrome browser and check out if we're able to render the attributes correctly in the DevTools. So now let's just refresh it. Okay, so we are in the application tab of the DevTools and the manifest here. So as you can see, it's able to identify or locate the manifest.json file there, but it seems there is an error. So for that reason, you're not able to render different values for different attributes, like the name, short name, and so on. So let's check out the error. So if we look at the console here, it says the manifest.json is not found. So let's debug. Okay, seems like we have a typo here. It's manifest.json. It has to be manifest. So let's fix that. So the browser should now be able to correctly load the manifest.json file. So let's go back to Chrome browser and check that out. Now refresh it. As you can see, the error is gone and the browser is able to load the manifest.json file, and you can see all the values have been loaded for different attributes. So the name, description, colors, and also you can see the icons here. It's able to load the icons of different sizes, so that's good. You can also see a warning here. It says that it's not able to detect a service worker. So let's fix that by implementing a service worker as well. So back to Visual Studio Code. So let's create another file in the root folder, and let's name it as sw.js. So service worker. So as we discussed in the theory part, that service worker has two lifecycle events: install and activate, and then we have the functional events like fetch, sync, and so on. So to make our web app installable, like a PWA, we need to add a handler for the fetch event. So apart from that, we'll also add handlers for the install and activate events, because later on in the series, we'll be working with caching, and those two event handlers would be of importance to implement logic related to the caching strategies. So let's start writing the handlers now. So that is the way to get access to the service worker entity and add event listener. So the first parameter is the name of the event. So start with install, and then the handler. So the function will get access to that event entity or object. So let's call it event. And for now, we'll just print it out to the console that the service worker is being installed. And to easily identify the logs from the service worker, let's make it more explicit. Let's say like service worker log, and then installing service worker. So that is the handler for the install event. So next is the activate event. Again here, we'll log to the console that the activation is in progress. Since activation signifies the completion of the install step, we'll just log that too. So for the activate handler, we'll have to write some additional code so that the service worker can start to take control over the HTML pages in the web app. That is to intercept different events that are triggered and then accordingly perform the actions in the background. So for that, we have to make the handler wait until that step is complete. That can be done with the method wait until. And in that, we have to write the line clients.claim. That is how the service worker would be able to get that control over different web pages and intercept the events. So that is the handler for the activate event. Next is the fetch event. So that is kind of a requirement to make our PWA installable. So let's get to that. We'll just copy paste this part to speed things up. So we'll just change the names here. Fetch. So we can just print out the resource that was requested. So for that, we'll change the codes to backcodes so that any expression is evaluated and the value is actually printed out in the console. So we'll have to use string interpolation for that. So that is $ and open and close curly braces, and within that we give our expression. So what we want to print is the resource or the URL that can be accessed with event, request, and URL. So since intercepting the fetch event, the service worker would act as a network proxy. It would have to return the response of the intercepted request. That could be done by another method like respond with. So instead of wait until here, it will be respond with. And inside, we give the actual fetch call for that requested resource. Fetch and event.request. So for now, we're keeping the fetch handler simple, but later on when we get into the caching strategies, we'll have a more complex code in the fetch event handler. So this is one part of incorporating service worker in our PWA. The second part is the registration of the service worker to the web app. That will be done in the app.js file. So in here, like we discussed in the theory part, first we have to check if the browser supports service workers. So that could be done with the if condition. If service worker, so it's camel case, the casing is important here. In navigator, so the navigator would be the browser. So if the browser supports service worker, then register the service worker. So it would be navigator.service worker and then the register method. So now, as you can see in the arguments, you have the script URL. So that should be the path to the service worker file, which is sw.js. And then you have options. So there you can give different attributes like scope. So since we're already giving the scope in manifest.json file, so that would be the default scope taken by the service worker. So let's give the path here, sw.js. So starting from the root. So the register method, it returns a promise because the registration takes some time, and we can access the end result, which is an object for the registration through the then method. So let's put it in the next line for better readability. Then we have a method in there. What we get back is an instance of the service worker registration. However, we won't be using the registration instance, so we'll just print to the console that the service worker has been registered. So that should complete incorporating the service worker in our PWA. So before we go to the Chrome browser and check if the service worker is detected by the browser, I just wanted to quickly show how the local HTTP server is being used here. So let's switch to the terminal. So I'm using hyper terminal here. If we scroll up, this is the command to start the local HTTP server. So since we're using node package, we're using the npm command and using the start script here to launch the HTTP server. So this is the command that launches the HTTP server locally. We haven't seen -1 option. It is to disable caching so that we can see any changes done to the code base instantly in the Chrome browser, and it runs on the port 8080. So that's the reason we access localhost 8080 in the URL. So all of this has been covered in more detail in my earlier video, like I mentioned, on creating a responsive layout. So do feel free to check that out as well. So now with this out of the way, let's go to the Chrome browser. Okay, we are on Chrome browser now. So before we refresh to see the changes reflected, the thing I want you to pay attention to is the address bar here. So here we don't yet have any icon asking to install the PWA. That's because the criteria hasn't been met yet. So once we refresh, if the browser is able to identify the service worker, we have met all the criteria, so it should pop up a new icon as an option to install the PWA. So let's check it out. I'm refreshing it. And as you can see, we are in the application tab and the service workers section. So it is able to identify the service worker and it has been activated as well. So you can see the status here, activated and is running. Also, I told you to keep an eye on the address bar. So you see we have a new icon here. So if we hover, you see we have that option to install the e-commerce app. So if we click on that, there we have the pop-up there to install the app. For now, let's cancel it because I want to show something else. So right now, when the criteria was met, the browser just added a new icon as an option to install the PWA. And then you actually had to click on the icon to get that prompt for the install button. So for better user experience, I think if this install banner was automatically prompted to the user, I think the user would be more likely to install the app. So rather than having the prompt right after the criteria is met, I want the banner to be popped up at a different place in the app flow, like when the user clicks on the shopping cart button to add an item to the shopping cart. So since at that point the user has already added the item to the cart, and it is more likely that the user is interested in the e-commerce platform to install the app as a PWA. So that is what we'll do next to defer the prompt until the user clicks on any shopping cart button and then pop up that install banner to install it as a PWA. So let's work on that next. So we're in app.js. To actually defer the prompt when the criteria is met, we actually have to record for an event before install prompt. So that is triggered when the criteria is met to make your PWA installable. So we need to add an event listener to that prompt, and we need to store it temporarily in a variable so that later on it can be accessed at a different location for the flow in the app to actually display the banner to the user for installation. So let's start with the global variable. So let's name it app install prompt. Let's initialize it to null to be safe. Now we need to add an event listener to the window object. So since the icon is displayed by the browser, that is the one that detects whether the criteria is met or not. So window effectively means the browser. So we add an event listener to the window object. Window.add event listener. And the name of the event is before install prompt. Then we have the handler like we did in service worker. So we prevent the default action of prompting the user. So we do that with the prevent default method of the event object. Also, let's log to the console that the event has been fired. Now we store the event in this global variable so that it can be used later in the app for the flow to actually prompt the user and install the PWA. So this is the code that we need in app.js to temporarily store in a global variable, and now we need to access it in product listing.js because there we have the logic to display the products and to handle the click event for adding an item to the shopping cart. So let's go to product listing. So in the product listing, we need to go to the handler for that shopping cart icon. So here we are, shopping cart button.onClick. So that is the handler for adding the item to the shopping cart. So we'll just add it at the bottom. So we'll just come down here and add the logic to prompt the user to install the PWA. So we'll check if there is a valid value in the global variable that we have in app.js. So that is another thing I would like to point out here. So we have the global variable in app.js right here. And we are trying to show the prompt at a different place in the app, which is product listing.js. So that is being made possible because of the way we wrote the code in index.html. Let's go there. So in index.html at the bottom where we have all the scripts, we first included the app.js, and right after that we have the product listing.js. So the ordering of these two scripts is critical here. So just wanted to point that out. So let's go to product listing.js, and here we first check if there is a valid value in the global variable. So if install prompt, so if it is not null, then perform some action. So let me scroll up a bit. So if there is a valid value, means the criteria has been met and the event has been saved to the global variable. So now we just prompt the user. So that could be done with the prompt method. So that will show the prompt to the user, and the user will decide on whether they want to install or not. It will take some time, so we need to know the end result, the user choice. So that could be done by using the user choice attribute. So like I said, it can take some time, so it will be a promise. So the end result can be accessed with the then method like we did before. So we have the end result as the outcome, and we can just print the outcome to the console. So we have to put it in back quotes again because we want to evaluate an expression. So that is the way to access the outcome. So irrespective of what the value is, this prompt is only done once. So we'll just print a message accordingly to the console. So if end result.outcome is dismissed, so that is a possible value for that. So if it is dismissed, just print to the console that the install has been cancelled. If not, the PWA has been installed, so we'll just print that out. After this, we just set the app install prompt to null because we just wanted to prompt the user once, and if the user chooses to not install it, we just leave them alone. So app install prompt equal to null. So that completes the code to prompt the banner at a different location, which in our case is clicking on the shopping cart button. So now let's go back to Chrome browser and check if it works or not. Okay, we're back on the Chrome browser. So what we want is when we click on the shopping cart button, we want the banner to be prompted out to the user. So let's refresh. So no errors, we still have the icon here, but what we want is when user clicks on that, we want the banner to automatically pop up. Let's try it out. There you see, when we clicked on it, item was added and we have the prompt automatically shown to the user. So it seems to be working. Now let's test it out on a mobile environment. So what we have in the browser here, it's not an actual mobile environment, but this is just components laid out as a mobile frame. So to actually test it out in a mobile environment, let's use an Android emulator. So for that, I'll use Android Studio, and in that virtual device manager in which we can test out our app. So before I start an Android Studio instance, I just wanted to go over the logs in the console. So here, if we scroll down, so you see we have the service worker log there. Since we had a message printed out for each resource that has been requested. So you see we have the name of each of the resources, like the images of different products, shoes, sunglasses, so on. You can see the manifest, you can see different shopping cart icons being accessed there. And also you see the result of the user action. So it has been dismissed since we didn't install the PWA locally. And also the message when the before install prompt was fired. So the logs can be helpful during the development process. Next, let me start an instance of Android Studio and we'll take it from there. Okay, we are on Android Studio, so you can just open up some default project because all we need is the emulator. So once you're in Android Studio, you can go to the AVD manager, just click on that icon and it will pop up any available virtual devices that you've already added. So I previously worked with some devices, so I have them listed here. So we'll go with Nexus 5X API 28. So if you don't already have any device, you can add one using create virtual device. So when you click on that, a new window will open and you see different devices listed here. So choose one that has the Play Store icon in it because that is the stable version. Once you choose one, say Pixel 4, you just click next, follow the steps to install the device emulator. So I'll just cancel this and I'll just go with the Nexus 5X there. So you just click on that play icon there, that will launch the emulator. So it might take some time, so I'll be back once the emulator is ready. Okay, the emulator is now ready. So as you can see, it has its own layout, just like a device. And you have different options here. So since the local host, it won't be accessible directly in the mobile environment, we have an alternate way of accessing it within the device through a specific IP. So let's open up an instance of the Chrome browser. So in the Chrome browser, let's add a tab, and in that we have to get to the address 10.0.2.2. So that will be the IP to access localhost within the mobile environment, and then the port 8080 on which the local HTTP server is listening for requests. So once you go to that URL, you see we're able to load our e-commerce platform there. The alignment of the top image is a little off, but yeah, the rest of the app seems to be rendering okay. Now if we click on the options of the browser, so you see you do have an option to add it to the home screen, like to install it locally. So when we click on that, you see you have that banner popped up asking the user to install it or to add it. So we'll just cancel it here. As you can see, the browser is able to detect that the criteria has been met for our PWA to be installable. So just the options are different compared to what we have in a desktop browser than that in the mobile browser. So next thing we want to check is for that prompt to be shown automatically to the user when we click on the shopping cart button. So let's try that out. So when we click on that, we add an item. For some reason, the banner is not being displayed automatically when we click on the shopping cart button. So let's try to add it manually with the add home screen button. So let's click on that. So you have the option there. Let's add it. So at home screen, now we have another prompt, add automatically. Now let's go to the home screen and see if the app is installed. So there you see, we have the EComm app being installed there. So if we click on it, so see, this is the splash screen. You see the icon, you can see the name of the app here before it's getting loaded. And at the top, you have the theme color that we gave in the manifest.json. So now you're able to see how the attributes or the values given in the manifest.json are being used when rendering the PWA. So if you click on this button to see the open items, open apps, you see this is a separate instance. You don't see the Chrome icon here. We see the icon of the shopping cart. So it is a standalone app here. If you come here, so here you see the actual browser, which is the Chrome browser. So after the installation, we're able to access the app as a standalone PWA with its own configuration. So now the app would be easily accessible to the user with a single tap, just like any native mobile app. And it works just like the normal web app. So logic seems to be working to satisfy the criteria to install our web app as a standalone PWA. So this is the Android emulator. So now let's check out on a real device too. So there is a way to actually connect your real device to your workstation, say a laptop or a PC, and see actually how it works in the real device. So let's do that next. Before the real device could be connected to your workstation, first we need to set up developer options on the actual device. So here is a neat article with information on the same. So we basically have to enable the developer options and also the USB debugging. We usually connect the device through a USB port to the workstation, and then we find the build number of the device through the About Phone option. And once you're there, we actually have to click on the build number 7 times. So it's kind of crazy, but that's how it's done to enable the developer options on your device. So once you have that, you would have the option to toggle USB debugging as well. So once that is done, then you can connect your device. So let's get back to the Chrome browser. So in here, I'll open a new tab. So Chrome, Inspect, and then Devices. So once you go there, you have to accept any prompt that you get on your real device to allow the USB debugging. Only then the communication will be possible between the device and the workstation. So this is the device that is currently connected to my workstation on port 8080. And the other important setting is port forwarding. So when we click here, you see I already have set up the port forwarding, like the 8080 to the localhost 8080. So this is important because when you try to access on your actual mobile environment, localhost 8080, the request will be forwarded to our local server, which in response would serve that request. That is how all this communication will be set up through port forwarding. Once you've done that, then you have to come in here and click on Inspect. That will open up a new tab where you'll be able to see whatever you're rendering on your actual device. So right now I don't have anything. So once I start opening the Chrome browser on the device, you'll start seeing something on the browser. So I've accessed localhost 8080 on my mobile device, and now I'm able to see that in the URL and also the rendered page here. So right now I'm interacting with the localhost on my mobile device, and you can see the interaction being transferred onto the browser here. So this is how you can connect your device and debug how it's running on the mobile environment and accordingly make any changes. So one thing to note, however, is that we won't be able to see any pop-ups like we set up the automatic prompt here. For that reason, I would have to record the screen capture on my mobile device. So let me start the recording and I'll be back. Okay, this is all the recording on the actual device. So as you can see, I'm still connected to my workstation through the USB, and I'm accessing the localhost like I normally would on the workstation. So the interaction seems to be fine, even though the top image again is a little off. So if you go to the browser options, you still have the option to install app, which is different than what you saw in the Android emulator. So still, when you click on the install app, you still see that pop-up there. So we're going to cancel this. What we want to again test is whether we'll get the prompt automatically when we add an item to the shopping cart. So let's try that out on the real device. So when I tap on the shopping cart, you see I have the prompt automatically shown to install the PWA. So the logic seems to be working, even though it didn't work in the emulator for some reason. So let's install it, and it's starting to install it. See, it's still adding the EComm PWA there. Okay, it has now added it to the home screen, so let's go there and check it out. Okay, see, we now have a PWA locally installed on a real mobile device. So let's click on it. Can you see the splash screen there, icon and the title of the app, and also the theme color at the top there. So again, I would like to show that this is a standalone app and not the actual browser, because you see you have at the top the Chrome icon, so that is the local host. And then this is the locally installed PWA. So this seems to be working on the local device too, to make your web app actually installable by incorporating PWA features. So let's try to add another item. So when we add it on the actual PWA, you don't get that prompt because it's a standalone app. And let's check out the items in the cart. So you have the cart there. So the functionality seems to be working, even though the layout needs some work. So this is how you can actually install a PWA on a real device, so that the users can have a better experience by accessing it through a single tab and interacting with it like a normal native mobile app. I hope you found this video helpful, and if you did, consider liking the video, subscribing to the channel, because there is more content coming along the way in this PWA series. So next in the series, we'll be looking into caching strategies, like different strategies for different resources. Some might be static, some might be dynamic, like the data rendered through an API call. So we'll incorporate those strategies into this e-commerce platform and discuss the ideas in a project-based fashion. So we'll just discuss different approaches and simultaneously keep adding the code to see it in action. Thanks for watching, and hope to see you in the next one.